Good morning everyone, and welcome to the presentation of the new master program in chemical engineering. I'm Isabella Nova, I'm the coordinator of the master degree program, and I'm here today with some other professors and some students that I will introduce to you. Professor Carlo Cavallotti, Professor Alessio Frassoldati, Professor Matteo Maestri, and Professor Davide Moscatelli. And we have today also two students with us, Veronica Marrocu and Davide Stramare. So the goal today is to show you the new structure of the master degree program in chemical engineering. So first of all, I would like to introduce you which were the motivations and the goals that we had in order to, that motivated our choice to change the structure of the master degree. And the first and most important goal was to improve the quality of teaching, to improve the quality of the students that we are forming at Politecnico di Milano. And to do that, we take into account three different aspects in order to improve the quality of the master degree program. We decided to renovate the offer, the topics, the content of the topics that the students have to go through for the master degree program, and to face that with the new societal challenges driven by the sustainable development goals. We decided to align the training offer to those offered by the other excellent university present in Europe. And we look also at the needs of the job market, which is continuously changing. So we wanted to adapt, to change our chemical degree master in order to meet the needs of the job market. So let me go into the details of these motivations. First of all, the topics, the content of the topics. Actually, we want our chemical engineering to have all the fundamental knowledge that is needed to face all the classical topics related to the chemical engineering and, let's say, the chemical industry and the petrochemical industry. But at the same time, we want our students to be able to deal with the new topics, the new societal challenges driven by the SDG, such as, for example, the carbon neutral energy transition or the climate change mitigation we have to go through right now. So these new modern challenges, new innovative technologies that the chemical engineer must be able to develop and to run in the near future. Also, of course, we are at Politecnico di Milano, which is located in Europe. It's located in one of the region with the highest GDP in Europe. And Europe has indeed many different universities, excellent universities in different region of the country. And Polymys and chemical engineering specifically is ranked among them. This has been defined recently by the QS World University Ranking that defined Polymys as first, ranked Polymys as first in Italy, as in the ninth position in Europe, and in the 30 positions in all around the world. So we want our students to be European students, actually able to move within Europe by exchanging programs, which are definitely present and offered to them by Politecnico di Milano. Students able to, in the future, to work everywhere they would like to. And for this, what we did was to refine the contents of the chemical engineering program in order to align the training offer and to facilitate in this way the movement, the exchanging program for the students. Finally, we look at the job market, and we look specifically at the request of the job market. At Polymys, we have a specific office, the career service, which is dedicated to the relationship between the students and the companies. And this office provided us with the main with the main employment sectors and the main areas of expertise for chemical engineering. So what we did was to structure the new chemical engineering program to meet the needs of the most important employment sectors for chemical engineering by providing also the knowledge and the tools which are needed in these major areas of expertise. So going into the structure, in the definition of the structure of the program, we have, of course, a 2-year program in which in the first year we have 60 ECTS of compulsory courses, while in the second year the students can gain more detailed knowledge by splitting in 4 different tracks and gaining 25 ECTS compulsory credits in these specific tracks. And then the final credits are gained by 15 ineligible courses that, of course, the students can freely choose. And 20 ECTS are finally dedicated to a research thesis project. So going into the details of the first year, as I told you before, this is dedicated to the gaining of the basic fundamental knowledge that is required for a chemical engineer to face all the topics he's willing to in the full job career. We have 60 ECTS with topics related to chemical and catalytic reaction engineering, advanced transport phenomena, applied physical chemistry, chemical plants and process operation management, process system engineering, and processes of the organic chemical industry. While in the second year, as I told you before, the students can choose among 4 different tracks that will allow her to gain more specific knowledge about one of the topics which are correlated to the tracks. We selected 4 different tracks: bio and pharma, energy and environment, process design, and a research and development track. So within each of these tracks, the students will have 25 ECTS to be taken by compulsory courses, and then to complete the program, we will have to choose freely 15 ECTS among many different topics, and we will show you in many different areas. And finally, as I told you before, 20 credits will be dedicated to a thesis project. So to go into the details of each specific track, I will change the speaker and ask Professor Moscatelli to tell us something about the biochemical and pharma track.
Thank you, Isabella. Good morning. So very briefly, in this track, our purpose is going to provide a key knowledge and to deep, specific aspects that are going to characterize the pharmaceutical and the bio companies. Just to name some of them, the sterilization, which is a key aspect of all of these, companies. The reproducibility of, in particular, the biomolecule, which is extremely strict, aspect that has to be fulfilled by those companies, is very, very peculiar for the pharmaceutical company. The high throughput, try to think about recently the breakthrough in the synthesis of vaccine for millions and billions of people for the COVID issue, and the concentration of the key molecules is very low in the bioreactors, and the reproducibility should be very high. The sterility should be fulfilled in all the aspects. So all of those aspects are very quite important, key for those companies. The biomanufacturing, which is a very peculiar process adopted in those companies, there will be need for deep understanding in the formulation technology, which plays an important role in the pharma and bio companies, and also the innovation, which is very, very important for those companies, which has also a peculiar aspect that will be taken into account. The final goal, the final aim will be to have chemical engineers with a very solid backgrounds in all the aspects that they can open the doors for them into the bio and the pharma world. Now, in detail, what are going to be the mandatory courses that we are offering in this track? So they are 5, each one covering 5 credits, and they are listed here in this table. So the flow chemistry, which is a very peculiar production process for molecules like pharmaceutical compound. The formulation technology, as I already said, which is a very key aspect for those companies. The manufacturing of pharmaceuticals, which is a course deepening all the steps in manufacturing, bioproducts. A course in pharmaceutical chemistry and technology, and finally, a course dedicated to the nanomedicine and the innovation in the pharmaceutical company. Thank you, Isabella.
Okay, so good morning, everyone. So I'm going to present you the track on environment and energy. So I think that everybody knows that energy, and in particular the sustainability, are already playing and will play even more in the future a pivotal role for our society and economy. In particular, sustainable development and energy transition will require the expertise that is typical of the chemical engineering profession, and our discipline will be actually unique at this interface. For this reason, we have decided to include a specific track on environment and energy, and the aim of this track is to provide up-to-date formation for the chemical engineer of the future. In particular, we are going to cover several aspects of the environment and energy problem that goes from processes to the prevention, monitoring, and abatement of emissions, the development of processes for the sustainable exploitation of energy and material resources, and very importantly, the synthesis of carbon neutral energy carriers and vectors, for example, the electric fuels of hydrogen. And another important aspect will be the possibility of storing renewable energy in the chemical bond, for example, also by using electrochemistry and electrocatalysis. For this reason, in order to cover all these different aspects, the track is going to include the following exams. So we have catalysis for energy and environment, which mainly cover the pivotal role of catalysis in this arena, for example, in the synthesis of the fuels, among them, so the activation of the CO2, thermochemical processes for carbon neutral energy transformation, which covers, very important processes for the production and exploitation of energy resources, electrochemical technology for energy production and storage. And the last two are two exams that are covering important aspects, for example, of the full, process, like life cycle assessment of material and processes in order to understand the overall sustainability of the process, and environmental impacts that covers basically, emissions going from pollutants, but also the other impacts that are, very important in several aspects of this problem. Thank you very much.
Thank you, Matteo. We can move to the next track, which is process design. I will leave the floor to Professor Soldati.
Thank you, Isabella. We know that in the process industry, the main objective is to deliver products which fulfill the specification and at the same time achieving the maximum economic benefit with the minimum environmental cost. Thus, process design involves the development, scale-up, and the optimization of a safe, sustainable, and economically attractive chemical process. The initial stage of process development are typically at the lab scale. Then the focus shifts to scaling up the synthesis by studying the process at the pilot scale. At the small scale, typically chemical kinetics and thermodynamics are investigated. Scale-up efforts then involve the investigation on the effect of mixing, heat and mass transfer limitation, separation technologies, etc., as well as the entire simulation of the process. Simulation and modeling tools are then used to exploit the fundamental knowledge collected at those lower scale to design an optimal process and to size the equipment involved. The design of all the major equipment involved in the process is performed in terms of mechanical sizing, fluid dynamic analysis, design of the control system, and of its logic. On the basis of these results, an economic evaluation of the whole process can also be performed. So overall, this track gives the students a complete knowledge on the different scales involved in process design, and also on the tools needed to incorporate sustainability and controllability in the design of novel processes. Next slide. We see here that we have 5 mandatory courses, each one with 5 credits. The first one, the course on sustainable process design for natural gas and energy careers, will focus on the energy careers for the energy transition. This course specifically will be in co-tutel with an engineering company active in this field. Process control and instrumentation laboratory will provide the students with the detailed knowledge on the instruments for process control, while the course on dynamics and control of chemical process, in this course, the student will learn in depth the dynamics of complex systems and control techniques at the plant-wide level. Process design principle and methods will introduce a systematic methods for process design and for process integration. Finally, mechanical system dynamics will focus on the methods to evaluate the stress in the mechanical system and to understand the failure of the mechanical system typically installed in chemical plants. Thank you.
Thank you, Alessio. Last but not least, the track dedicated to R&D for industrial applications, Professor Cavallotti.
Thank you, Isabella. Good morning to everybody. I'm Carlo Cavallotti. I will be one of the teachers of this track. This is the reason why I'm doing this brief introduction. So where comes the idea of having a track that's dedicated to research and development? Well, exactly because the industry is requiring us to have some professionals formed with the skills needed to do research and to foster development. So to discover new things that can be useful for the chemical industry. Now, what type of skills do you need in order to perform research at the level that we want it to be done in the field of chemical engineering? Well, concepts that have been brought forward concerning research in chemical engineering related areas are all invoke these concepts that I report in these slides on the right part of the panel, where you want to connect the knowledge that's coming from the understanding of processes taking place at the molecular scale, which are typically described by quantum mechanical equations, up to the industrial scale. So what type of knowledge, what type of skills do you need to be able to connect an understanding that comes from the molecular level up to applications that are at the industrial level? And please, by industrial level, we talk about huge scale plants such as refineries, so a very large scale. Well, first of all, you need to increase your understanding of molecular processes. So if you look at this slide, that would be the quantum mechanics part, where the time scale and the length scale is that of the angstrom of the picoseconds. Then you would need to extrapolate these processes across different length scale up to what we call the reactor scale. So, for example, going from molecular aspect to the reactor scale, you need to have something that allows you to do molecular simulation of this system. So for continuous simulation of this system. So means using the continuum equation means that usually this implies using the finite element methods, and it implies using generally softwares that are available in the literatures, but for which you need to strengthen your mathematical background. And finally, you need to apply this knowledge up to the study of a real process. So you need to strengthen your understanding and your comprehensions of some fundamental aspects related to areas that are of key relevance for us in chemical engineering, such as separation. In this example, on the right part of this panel, we see a chemical vapor deposition reactor for electronic applications, where you need to know adsorption, that is a key aspect of separation, and catalysis if you want to transform some species into another species. So what type of course have we selected in order to favor your the development of the skills that are required? Well, we need to strengthen our mathematical background, so advanced mathematical analysis. Please don't be too scared about this. It will be mostly informative, non-selective, and maybe with something about the recent evolving field of artificial intelligence. Then we needed to be able to work in a lab. So we have a course on catalytical kinetic investigation, as well as applied chemistry for technology, where really the students involved in this track will be working on in a real lab. Then we have some aspect of some focus on molecular aspect through chemical kinetics and dynamics class. And then, as I was saying, we will have this course on adsorption and membrane separation, where we look at the fundamental of these very important aspects. Just to conclude this presentation, in order to be able to form you, the people who choose this track, we will have a limited number of people who can access this track, so that you can have really hands-on experience both in the lab and both through computer simulation. Thank you, Isabella. That's all.
Thank you, Carlo. Thank you very much. So we can complete the overview of the program by looking at the list of the eligible courses. You have 15 credits to choose freely among all these topics, which actually cover many different aspects related to chemical engineering. So energy, environment, or process design, biotechnologies, biochemistry, safety and risk management, catalysis and electrochemistry, physical chemistry, polymer chemistry, corrosion, or unit operation, instrumentation and control. And to complete actually the program, to complete the part related to what you can freely choose, you have to spend to take 20 credits, to dedicate 20 credits to a research thesis project. Well, for our program, this is a one-year research work spent in the labs, actually doing a theoretical or experimental work, which has to be strongly original. So it must have a very soundproof, scientifically and technology innovative content. And this can be done in the many labs that are actually available for thesis work, labs that cover many different aspects, all the aspects that we listed before for the eligible courses. So you can pick up what your interest is in. You can follow your passion in chemical engineering, working in labs which are in two different departments, the Department of Chemistry, Material and Chemical Engineering and the Department of Energy. And all of them have a very solid reputation at the world level. So finally, a couple of words on who can enroll in the master degree. Well, to do that, you have to hold a bachelor degree in a relevant subject, that is a chemical engineering bachelor degree or something related to chemistry. You must have a specific score, which is evaluated on the basis of the number of semesters you use to get the bachelor degree and on the score you got from the previous degree. You must hold an English language certification recognized by Polimi, again with a specific score. And you must present, of course, an application that will be evaluated by a specific commission that will analyze not only the thing listed before, but also your curriculum vitae and studiorum. And you can find all the detailed information at this site here. Finally, let me let the students talk, and I would like to invite Veronica maybe first, as a girl, to tell us something about what she's experiencing now at Milano, at Polimi.
Good morning. My name is Veronica, and I'm a student in the third year of the bachelor's degree in chemical engineering. I'm also at the end of my career, and I want to continue my studies in this area. Among the things that convinced me to enroll in the new master degree are the strong innovative character and the fact that it has been structured taking inspiration from other excellent European universities and polytechnics, while still maintaining several key and traditional exams that characterize the last master degree. I intend to live on Erasmus in the second semester of the next academic year, and choosing the master degree facilitates me because it has been made flexible for students living on Erasmus by dividing the exam of 10 credits into exams from 2 modules of 5 credits. Another interesting thing is the subdivision in the second year into 4 courses, and I personally am very interested in the environment and energy and process and design.
Thank you, Veronica. Davide?
Hello, everybody. I'm Davide, and I'm like a student that is nearly finishing the master degree. So I actually studied all the old version of the master degree, and so I can judge how it was. And it was nice, but I think at some point it was also kind of confusing because the structure was completely different. We was more freely. We can choose more courses, but we have some constraints. But even though we have these constraints, the focus wasn't so good on specific aspects as it is now with these 4 tracks. So I think that the new structure with the first common year and then different tracks allows to better have a better focus on the different themes we explained before. And so I think it will be like a great master degree. And I would also, if I would have been able, I would like to do this new master degree.
Well, you're welcome to do that, actually. I'm just joking, of course, but thank you. So I think there was the need to change this program, and I think we will see in a couple of years if we have succeeded in our goals. Well, to conclude, let me just tell you where you can find more infos about the program and anything that is needed to apply for it. We have a specific link to our course, to our program course, which is reported here. And actually, this is in Italian and in English, and you can find all the information to deal with that. You have information about the course, about the teachers, about the labs, about different opportunities that you may have, about seminars that we all related to the chemical engineering world. Let me just mention also the site, the website of Polimi. So the classical website. Specifically, you have to search for the School of Industrial and Information Engineering, where you will find the rules, the educational rules, which are the document, the reference document with all the information that you need to apply and for the proper description of the course. Actually, to this point, you can get also from the website of our degree master program. Also, we are social, actually, so I would like to invite you to join us on Instagram, on Facebook, and to look on YouTube to the Chemical Engineer Polimi, where you can find all the registration of many different events that are correlated to chemical engineers. And with this, I would like to thank actually all the speakers for their contribution, to thank you to have been able to follow us today. And we're looking forward to having you on board of the new master degree program in chemical engineering. Thank you.
Thank you very much.
Thank you.
Thank you.
Thank you.